we're going to go through another one proportion hypothesis test and look at all 4 steps once again. A friend says that he did a survey and he claims that 70% of teenagers prefer bottled water to tap water. Now 70% seems low to me. If I had a choice between bottled water and tap water, I would pick bottled water. It seems to be cleaner, doesn't seem to have as much residue to me. So I think it's higher than 70%. I think maybe it's 80% or 90% or even 95%. So in order to check out this claim, we randomly sample 90 teenagers. We find that 75 prefer bottled water to tap water. We want to know what can we conclude with a 5% level of significance. So we're going to walk through all 4 steps for a hypothesis test. So step 1, I need to give my HO and my HA, my null and my alternative. HO has the form P equals some value. I use my baseline. I use my friend's survey. He claims that it's 70%. So P is equal to 0.70. Now, to me, that seems low. I don't think it's 70%. I think it's higher than that. So I'm going to go with greater than 0.70. It should be P is greater than 0.70. 70% is too low. I think it's 80% or 90%. Note, these are claims about the population. I can't talk to every single teenager on the planet, so we have a random sample of 90 that we're going to base this off of. My second step, I need to check the central limit theorem. So for my central limit theorem, I need to make sure it is a random sample. I can say that is met because it says you randomly sample 90 teenagers. My expected success is my N times P. My sample size is 90 times P was set to be 0.70 up here. Say 90 times 0.70 or 0.7 gives me 63. N times 1 minus P, 90 times 1 minus 0.70. You could type this in 90 parentheses 1 minus 0.7 or 0.70. Gives me 27. Or you could have used the fact that these two have to add to be 90, which 63 and 27 do. Because they're both over 10, 63 and 27, this condition is met. So that tells me I can use the theories of the normal distribution. I have a nice bell-shaped curve. I'm going to put my P of 0.70 in the middle. Now I want to see, well, where did my sample fall? Did it get close to 0.70? Was it actually above 0.70? And I also want to know, well, what was the z-score on that and what's the p-value on that? Because the p-value, as we saw in the last video, is very important. So for that third step, I want to find my z-score, my p-value, and my p-hat. To do that, I'm going to go to stat test number 5. This is a hypothesis test. We're looking for a z-score, so it's a z-test. It's one proportion. We're just dealing with one percentage here. So number 5. P sub O is 0.70. X is my actual number of successes, not my expected. It's not 63, but I need to use this information about the sample. There were 90 teenagers, that's my N, and 75 said, yes, I prefer bottled water to tap water. So X is 75. N is my sample size of 90. And I'll select this greater than symbol because that's what's in my alternative. And then I'll hit calculate and I'll see these 3 values that I need. My z-score is 2.76. My p-value is 0.0029. And my p-hat is 0.83. So what this tells me on my normal distribution is that my p-hat is unusual. It's an outlier. It says z-score of 2.76. 0.83 is so far above 0.70 that it's unusual. It's an outlier. The area in this tail up here, this is what the p-value is. This is 0.0029. So I can see I didn't get exactly 70%, and we know samples are going to vary. But is 83% high above enough 70% to change my mind, to say, well, my friend's claim seems to be wrong. Maybe he did something wrong statistically. And to decide, do I accept that it's 70% or do I go with the idea that it's greater than 70%? I'm going to go to that fourth step. I'm going to compare my p-value to my level of significance. So for this fourth and final step, my p-value, once again, is less than my alpha. The p-value is 0.0029. That is less than 0.05, this 5%. When that's the case, we reject HO. So HO was p equals 0.70. We're rejecting that idea. The statistics don't back this up. Instead, we could say the data are statistically significant to conclude more than 70% of teenagers prefer bottled water. Our sample proportion of 83% was high enough above 70% statistically that we can say 70% seems to be too low.